Okay, so as a binomial distribution also has a mean and a standard deviation, a continuous distribution does as well. All right. So our continuous distribution, the mean for the continuous distribution, is just given by the rule x times p of x. Okay, so in the same way, if you remember when we had our probability distributions, we might have had, I don't know, 0, 1, 2, and we might have had a quarter, a quarter. Well, the mean was x times p of x, where we did 0 times a quarter plus 1 times a half plus 2 times a quarter, and just worked out the expected value. Well, really, that's what we're doing. We're doing x times p of x. And so that's just that rule there. So my expected value, which we use the mu symbol for, is the same integral over the same limits of integration. We just do x times the probability of x. So in other words, x times the function. And if by chance we've got a function there to say the expected value of some g of x function, we just multiply the functions together. All right, so let's have a look. Find the expected value of x. So that's my probability distribution. So what is the mean value? So if I did that a quick sketch, that's a half x. So what is the average value of that function? All right, so don't forget that would be the rest of the function like that. So the expected value e of x, so e of x is equal to the integral between 0 and 2 of x times whatever the function happens to be, which in this case is a half x. Okay, so that's equal to, take the half out the front of x squared, so x to the 3 on 3, evaluated between 2 and 0, which is a half times 2 cubed is 8, minus 0, which is equal to 4 on 3. So that's the expected value. So that's mu, all right? The expected value of e to the x, correct to 4 decimal places, which I must confess I have trouble explaining what it is in the concept of the problem, but mathematically, 0 to 2, let's take out the half, okay? It's just whatever the function happens to be times, now let's leave that half, so it's just e to the x times f of x dx, okay? So now I'll take the half out the front, integral between 0 and 2 of x e to the x. Now we don't know that, so using my CAS, I would get 4.19 4 decimal places, 4.5. Okay, so just remember the expected value x times p of x. We got nothing else on this. Okay, so the percentiles and median just refer to, I guess, the middle of our data. The median is certainly going to be our middle of our data, as in a median strip. You may have seen it in statistics. The percentiles just refer to a particular quarter or particular percentage of data that fits under a certain point. So, for example, the 75th percentile suggests then that the area under the curve is going to be 0.75. Our median data, well, that's the values here. That's the value there for M, that half of our data under the curve lies. In other words, the probability of the data is only equal to 0.45. So that's what my median is. So if I want to find the median of our data, what I'm in reality looking to do is I'm trying to find the value, well, in this case, the lower limit is 0, up to whatever value M is, where 2 times 1 minus x dx is equal to a half. Okay, so I could also, if I wanted to, find where the top half of the data is. So either one of those will work. Yeah, so it's just the middle to the end or the bottom to the middle. So let's come back in here, 2 times the integral of x minus x squared on 2 between m and 0, which is equal to 2 times, put m minus m squared on 2 minus 0, which is 2 times m minus a half m squared, and that equals a half. Let's bring that across here. So if I multiply that 2 through, I'll get 2m minus m squared is equal to a half, which means m squared minus 2m plus a half is equal to 0. Using my CAS there, or quadratic formula, all right, complete the square. There's a range of different things we could do here. You know, just as easy for me to write that as m minus 1 all squared plus 1 minus 1 plus a half. So it's m minus 1 all squared is equal to a half. M equals 1 plus or minus 1 on root 2. Yeah? So we'll find that those two possible solutions. I need the one m equal to 1 plus 1 on root 2 is outside the domain. Therefore, I need m equal to 1 minus 1 on root 2. So that's the value. So the probability, so really what that means is, if I come up here, the probability of being between 0 and 1 minus 1 on root 2 of 2 times 1 minus x dx is equal to 0.5. That's my median value. All right?